Alright, so here's basic time value of money. Let's say that, and imagine this is a nicely drawn machine. Let's call it a printer. Call this the magic money machine. This magic money machine, I guarantee you, and you believe me 100%, will pay out in exactly 1 year. Exactly 1 year, it will pay $10,000. The question is, how much money will you give me for that machine? Alright, let's just say that you tell me you would pay me today $9,131. So this is what you want to look at. This is today you will pay $9,131 to get $10,000 in 1 year. Why do you do that? You don't do it to get more money. I want to be a little more precise in the language. You give up $9,131 worth of purchasing power. So rather than spending that amount of money however you want to, you're going to invest that and you will get $10,000 back in 1 year. You only give up the ability to purchase stuff today so you can purchase more stuff in the future. So if you imagine taking a trip, taking a cruise, say I could take a cruise this week, it's going to cost me $9,100, but I decide instead to invest that and take the cruise next year. The reason I'll do that is because that $10,000 is going to buy me a nicer cruise next year, and I'm willing to wait so I can have a better room, longer time, whatever. But we know the prices are going to go up in that time period. So two things are going to happen. I need to increase my purchasing power to get more stuff. That's my real rate of return. But also the prices of stuff are going to go up. So that's going to erode my purchasing power. That's inflation. So I'm giving up money today, and to give up money today I have to be compensated for these two things. Here's the mathematical equation. The present value of $9,131 is equal to the future value, the $10,000, divided by 1 plus R. Let me kind of tell you how I would get that equation. If I were to tell you, if you put $100 in the bank today and an interest rate of 10%, most people tell me you will have $110 in the bank next year, right? So how did you do that? You said the $110 is equal to $100 times 1 plus the interest rate. So that's the future value is equal to the present value times 1 plus R. But what if it was in the bank for 2 years? Well, that would grow to $121. How do I get that? Well, $100 times 10% becomes $110. The $110 compounds, and now I quote the interest based on this. The $110 grows at 10% and becomes $121. So really, that 121 is equal to the 100 times 1.1 times 1.1 again, which really means that's 100 times 1.10 squared. So the rule is the future value is equal to the present value times 1 plus R squared. And that's what I have over here. The present value, the amount I give up today, is equal to the future value divided by 1 plus R to the first, because it's exactly 1 year. And now I can determine what my interest rate is. By solving for this equation, I can write it like this. 10,000 is equal to 9,131 times 1.09529. And there may be some roundings in there, but close enough. Alright. The reason I use this example, I say you're willing to pay $9,130 today to get $10,000 in a year. I want to think about some rules for time value of money. Well, if I was to tell you that it doesn't pay in 1 year, instead it pays you $10,000 in 2 years. Would you pay more or less for the would you pay more or less for the money machine? And your answer, I hope, is less. I would rather get the $10,000 in a year than $10,000 in 2 years. So, timing matters. And $10,000, would you rather have, which money machine would you rather have? One that pays $10,000 in a year or one that pays $5,000 in a year? Well, you'd rather have the one that pays more, right? So size matters. So the size and timing of the cash flows matters. The more you're going to get paid in the future, the more you're willing to give up today. The sooner it is, the more you're willing to give up. The further in the future, the less you're willing to give up. But why further to tell you this? The money machine is going to flip a coin. So instead of paying $10,000 for sure, flip a coin, you get heads, it'll pay $20,000. Tails, you get $0. Most people would say they would rather have the $10,000 for sure. So I would pay less than $9,130 for a machine that flips a coin. So this introduces risk. So there are three things: size, timing, and risk of cash flows. So all of finance really comes down to this. We're trying to figure out the size, timing, and risk of the cash flows. So this goes into what we'll be doing with the bonds. The bonds, however, don't make just one payment. So I didn't mean to shift that around like that. Get rid of that. So let's say that we have the following. You're promised $1,000 in a year and $1,000 in 2 years. Remember the rule: the present value is equal to the future value divided by 1 plus r to the t. And then that's the ugly t to the t. So I have two cash flows. This one, and let's say, to make it simple, the interest rate is 10%. So I would be willing to pay you whatever this number is, which is $909.09. I'd be willing to pay you this amount to receive that cash flow, the $1,000 cash flow that comes in year 1. But the cash flow that comes in year 2 squared. Let me pause and get these numbers. Okay, so I did some quick math here. I know my writing is bad. I'm willing to pay $909.09 to receive that cash flow in exactly a year. I'm willing to pay $826.45 to receive the cash flow in 2 years. So I will pay $1735.54 to get the two cash flows together. So I can do this, as often as far as I want to. Well, if I have 5 cash flows of $1,000, let's put 100 so I can have less zeros to write, at 10%. So that's 100 divided by 1.10 to the first. This is 100 divided by 1.10 squared. This is 100 divided by 1.10, guess cubed. This is 100 divided by 1.10 to the fourth. This is 100 divided by 1.10 to the fifth. So the value of all those is just sum those up. That looks like a lot of work now, right? It was easy enough when there's one cash flow. Oh yeah, 1,000 divided by 1.1, that's 9099. I got that. 2 cash flows, that's not too much work. I take the 1,000 in year 2, divide by 1.1 squared, just add the two numbers together. You give me 5 cash flows, and now it's starting to be a lot of work. Well, it turns out there's an easy way to do this. This is called an annuity. So if I have a cash flow, multiple cash flows, that's an annuity. So let me give you a couple examples of that. I'm going to leave some of this to your 8135 instructor. I was going to give you the, I guess the minimum I can here to make sure you understand this without a lot of detail. So let's say that I'm offering you a cash flow of $500 per year for 10 years. So you're going to get $500 a year for 10 years. So I know the payout rule. The payout rule is N is equal to 10 because I get 10 payments. The payments are equal to 500. And you have a financial calculator that's built for a specific problem where you have cash flows that look like this, and in the end you get some extra payment. That's called the future value. In this case, you don't get any extra payment. The future value is equal to 0. So this is my payout rule. I have a button on my calculator that tells me my yield to maturity, and I'm saying there's a 7%. That in order for me to make this investment, to think of as loaning money, in order to loan someone this money, I need a 7% return. So what I'm doing is the present value of those future cash flows is 500 divided by 1.07 to the first plus 500 divided by 1.07 squared plus ... 500 divided by 1.07 to the 10th. All that turns out to be 3511.79. So this is saying, here's kind of the concept here. I'm willing to give up $3,511.79 today to get $500 per year for the next 10 years, with the first payment coming in exactly 1 year. So this concept is how we value bonds. So let me give you another bond example. Okay, so let's say that I sell you a bond. When I sell you that bond, I have to tell you the payout rule. I tell you the payout rule, and this is on a physical certificate, an actual piece of paper somewhere, that says this bond is going to mature in 8 years. I'm sorry, 4 years. So 4 years to maturity. It's going to have a coupon rate of 5% and a par value of $1,000, and it's going to pay semi-annually. From that information, and I'm assuming, by the way, the next payment comes in exactly 1 period. So from that information, I know that this thing is going to pay 8 times, right? Because there's 4 years to maturity, it pays semi-annually, it must make 8 payments. What are the payments? The payments are the coupon rate times par. Those are the annual payments. So 5% of 1,000 is $50. So it pays $50 each year, but makes 2 payments a year. So it pays me $25 every 6 months. And at the end it pays the par value of $1,000. So that's the payout rule. Your financial calculator is specifically designed to handle this payout rule. I can say N is equal to 8, the payment is equal to 25, the future value is equal to 1,000. So once again, this is my payout rule. My next question is, what if I'm going to loan money, what rate do I loan? How much return, how much yield do I need to get to buy this bond? So the yield to maturity is 5.2%. How do I come up with this? The same way if you go to buy a house or a car and they loan you money, the bank loans you money to buy the house or car, they run your credit score. Based on your credit score, we need this certain return because of your level of risk. And they quote you that in annual terms, but the payments are made semi-annually. So divide that by 2. That will be 2.6%. So the price of this bond is equal to 25 over 1.026 plus 25 over 1.026 squared plus 25 over 1.026 cubed plus, let me skip some here, 1025 over 1.026 to the 8th. That's going to take you a long time to do that. Your calculator is built to do it quickly like that, and it should come out to be 992.86. Okay, so given that information, you should be able to start with Chapter 14. If you have questions with it and how to use your calculator, I'll be happy to walk you through those.